Alright, so we already did some Punnet Squares forward, and hopefully you've mastered those. So now we're going to talk about Punnet Squared backwards. So before we were given the parents, and you had to find the possibilities of the children. So now we're going to work backwards. What were if you were given a whole set of children, a whole set of mice or something, and you needed to find out what the parents were for whatever reason? You had to find out what kind of genes the parents had. So what we're going to do is give you some practice problems here, and all you're going to do is find the genotypes and phenotypes of the parents. Alright, so 1/4 of the children are short, 3/4 are tall. Alright, so what does that look like? Well, if you remember your pedigrees, we can't get, there's no way we can get this. Alright, so don't write this down. You can't get that and have that. There's no physical way. If we put a big T or a big T here, it would have to go into those boxes. So tall cannot be the short. Tall has to be dominant. It can't be recessive because 3/4 is 75%. 1/4 is 25%. So there should be three boxes that would be recessive. So if tall was recessive. So now let's do it the other way. Let's say short is recessive. Well, there's one box that's recessive, and then the rest are all going to be tall. So they only need to have one capital letter to be tall. So let's do our Punnet Square backwards now. So we know there's two little t's in this box right here. So I'll put a little t up here because that puts a little t there, and a little t here and puts a little t there. All right, so we know that those little t's. So then we have to fill in these. And then in order to get a big T to go across and to go down, we have to put a big T here and a big T here. Alright, because that puts this big T in both of those boxes, a big T in both of those boxes. And there you go. So our parents' genotypes are both big T, little t, big T, little t. We don't have to put in percentages because we know that is what it's not a probability that one of these parents is going to be that. It is. That's what the parents had to be in order to get this ratio of kids. And then the phenotypes are, they're both going to be tall. Alright. This one's easy. All the mice are white. Alright, doesn't matter if, and it says white is a recessive trait. So they're all white. So what are the parents going to have to be? Well, the only thing that's going to give you the white recessive trait is recessive parents. So the genotype of the parents would be little r, and the phenotype is going to be white. Alright, if we go back up to this first one, 3/4, 1/4, if you just memorize that two heterozygotes are two heterozygote parents here, two big T, little t, if you remember that that always gives you 3/4 to 1/4 or 75-25% as far as the phenotypes go, then you'll be golden. You'll always remember that, and you actually don't even have to do these Punnet squares backwards. But if you don't memorize those, that's how you can do this. Alright, so let's do these last couple ones here. Alright, so now, this was a little bit trickier. So it says 25 of the mice are homozygous dominant and 25 are heterozygous. Well, this isn't saying 25%, it's saying 25 of the baby mice are that. So what we're going to have to do is figure out what percents are these if they're both 25. So our phenotype percentages are 100% to 0, 75-25, or 50-50. That's the only percentages you're going to have. So 25 to 25, since these are equal, well, that's 50-50. 50-50 are equal. So it's going to have to be a 50%, 50%. So that means half of our boxes are homozygous dominant. What does that mean? Same, and they're both big letters. So half of our boxes have two big letters, and the other half of the boxes are heterozygous, big little. All right, so then you just know that since there's a little r here and a little r here, this has to be a little r, and then the rest of them all have to be big R's. All right, so you get big R, little r. Um, and big R for the parents' genotypes, and for the parents' phenotypes, they would both be. Now, I didn't give you a phenotype, so we're just going to leave that blank, but they're going to be dominant because it has the big R's. They're both going to be dominant. All right, this one, 45 of the mice are white and 52 of the mice are gray. Well, now this is tricky because they're not exactly equal. All right, but they're not really that far apart either. All right, so they're definitely not 100 to 0 because none of these are 0. All right, so it's definitely not this one. So it's either these two. In order for this to be 75-25, you would see something closer to a farther away number. 45 and 52 are only 7 apart, and these are fairly big numbers. So this is still a 50-50. Because what happens is this is just probability here. This doesn't mean you're actually going to get 50%, 50% all the time. It just means that's most likely. So if this is 50-50 again, half of them are white, which we know white up here is dominant. So they all have to have a big R. And then half of them are recessive, so they all have to have, those two have to have two little R's. And then we know a little r has to be here, and then a little r, and then a big R. So we get two little r's in here, two little r's in here, so there had to be a little r up here to go down there, and then both little r's on here to fill in here. And then in order to get a big R in these boxes over here, we had to put a big R up here. All right, so our genotypes for our parents would be big R, and little r. And their phenotypes would be, this one would be white, because it's dominant, it has a big R, and this would be gray, because it's recessive. All right, so we got two more here. All right, so now 35 to 10. Now that's like 15 apart. That's pretty far away. So that is more like our 75-25 percentages. So that means 3 of our boxes, and crap, I didn't do this right because we were just talking about white was dominant. But in this one, white would have to be recessive because you can't have 3 of the boxes be recessive. One of the boxes be dominant and 3 of them be the recessive for the gray. So in this one, white had to be recessive and gray is going to be dominant. All right, dominant is usually always the one that comes up more. So we have 3 boxes that are dominant, 1 box that's recessive, white. All right, and remember, little r up there, little r here, and that's how we get our 2 little r's there. So we can fill in those 2 boxes with little r's, and then our big R, and our big R to get our big R's down. Alright, so remember again, they're both heterozygotes, or they're both gray. Alright, and now 50% of the mice are homozygous dominant, 100% are gray. So now we're assuming that, again, gray is dominant. 100% are gray. Well, let's start with the 50% are homozygous dominant. So that's easy, because half of the boxes have to be big R, because half of the kids are big R, or homozygous dominant. If 100% are gray, so that means the other ones have to have a big R, but if only 50% are homozygous dominant, that means the other 2 have to be heterozygous. So a little r has to go up here to get little r in those boxes, and then the rest of them will all be big R's. Alright, so this one's a little bit trickier, but if you just use some reasoning and draw out your Punnet Squares, you should be able to figure it out. Oh, and I never write down. So the genotypes for the parents here would be big R, and big R, little r, And the phenotypes would be, they would all be gray.